Hello, this is Mr. T. I have a tutorial today to help you prep for the upcoming quiz we have. The quiz covers a number of miscellaneous topics that we're finishing up here as we head towards midterms. Our first problem is finding all the zeros of a function. Remember, the number of zeros we're looking for is the same as the degree, which is the biggest exponent. So we're looking for this problem, we're looking for 3 zeros. So if we, now there can be zeros, can be real numbers, and then they can be complex numbers. To find the real zeros, we're going to use a graphing calculator. So to find the real zeros using the graphing calculator, we first have to enter our function into our graphing calculator in the graphing portion. So we want to go to y equals, clear out the function that's there, and now we need to type in our function here. It's x cubed, so use the caret key for our function, and then minus 2x squared plus 4x minus 8. And we want to graph that. Now to get the standard window, we want to press zoom and then select item 6. Now where it crosses the x-axis is a 0, so we can either use second calc and number 2, 0, and put in our left bound, right bound things. But on this thing, if we look at the graph, it looks like it's crossing at a whole number. It looks like it's crossing at x equals 2. So we can press second and the graph button, which gives us table, and scroll down and see, indeed, do we have a y value of 0 at x equals 2. So we have a real 0 of x equals 2. And we don't see any others on the graphing calculator, so we can put the graphing calculator away. To find the complex zeros, we need to divide out this 0 using synthetic division. So we make our synthetic division symbol, which is kind of the up-down divide. We put our 0, whatever we found from the calculator, out here. And we put the coefficients, so a 1, a -2, a 4, and a -8 into our synthetic division. So we have here 1, -2, 4, and -8. If I had been missing any of the powers of x, and this one I have an x cubed, an x squared, and x, and then a constant, I would have to fill in zeros. But in this one, we don't need any zeros. We bring our first number down, so that's a 1. And now we're going to repeatedly multiply and add. So we're going to multiply this 1 times the 2 in the front, and we get 2, and put in that in the next column over. And now we're going to add those two numbers, so -2 plus 2 is 0. And now we repeat, 0 times 2 is 0. Add 4 and 0, we get 4. 4 times 2 is 8. We add and we get 0. This last number here is the remainder, which, given that we knew that x equals 2 was a 0, it should divide evenly. So we kind of throw away the remainder. If you did not get 0 there, you would have either had made a mistake with the calculator on finding the 0, or you made a mistake on the synthetic division. These three numbers here, the 1, 0, and 4, are the coefficients of a new polynomial that is 1 degree or 1 exponent smaller than the original one. So this represents y equals x squared minus 0x plus 4, which would be x squared plus 4. And we're wanting to find the zeros of that, which means we want to set y equal to 0. So we want to solve this for equal to 0. Now we have a quadratic equation here, which we could solve by square roots. If it had an x term, we would have to use either completing the square, factoring, or quadratic formula. Since they're complex zeros, most likely it would be completing the square or quadratic formula. In this case, we can subtract the 4, and we get x squared equals -4. And we square root both sides, so we get x equals plus or minus the square root of -4, which, if you remember from the unit on complex numbers, is plus or minus 2i. So our final answer, our zeros, are a real 0 of 2 and two complex numbers, zeros, plus 2i and negative 2i. Again, we've got 3 zeros, and our original problem was a x to the third. So that's finding zeros. So let's move on to our next problem. Our next problem is using exponent properties to simplify. Now remember, when we have an x thing base and an x multiplied together, we add the exponents. So our answer here is going to be x to the 2/3 plus 1/4. You could use the graphing calculator if you need to solve that. I would do it using, regular math, but let's review the graphing calculator. So let me clear out of here. Clear that out. So I need to do 2/3 plus 1/4. And I want my answer as a fraction, so we press the math button and item 1, and I get 11/12. So my exponent here is going to be x to the 11/12. And we're done with that problem. Here we have an exponent on the outside of a parentheses. It's called a power to a power, and we want to multiply the exponents. And we also have to distribute the exponent of 3 to everything in the parentheses. So my first step is I would have 3 cubed. And then on the x, I have to multiply 2 times 3, so I get 6. And for the y, I have to multiply 3 times negative 1, I get negative 3. If you have a negative exponent, we want to make it a fraction, so I'm going to put it over 1. And the item with the negative exponent must be moved to the other side of the fraction, and we change the sign. I'm also going to simplify 3 cubed. 3 cubed is 27, x to the 6th, and now the y is on the bottom, and I change the sign of its exponent. It's now y cubed. So again, that's our answer for the second one. This was our answer for the first. For C, the trick, or the skill is to pair up numbers together, x things together, and y's, and use our rules. Now, the 6 and 8 are just a regular fraction that simplifies to be 3/4. And on the x's, when we're dividing, we're going to subtract our exponents. So for the x, we are doing 3 minus 4, that's negative 1. And for the y, we have 2 minus a negative 1, so 2 minus a negative 1. That gives us 3, so we have y cubed. And just like the last problem, we have a term with a negative exponent, and it moves to the bottom. The 3 stays here. It has a positive exponent of 1, so we end up with 3y cubed over 4x. Okay, that's our problem 2. Let's look at problem 3, another topic, solving radical equations. Solving radical equations, we need to get rid of a radical symbol. The inverse of a radical symbol is squaring. So we're going to square both sides of the equation. The issue on radical equations is when we get to the end, the answers are only possible or suggested answers. They might be extraneous, and we have to check them. We'll see that at the end. So my first step is to square both sides. On the left side, if you square something that's under a square root symbol, those are inverse operations. It just undoes the square root. On the right side, we have to FOIL this out. It becomes x minus 3 times x minus 3. If I FOIL that out and simplify it, I get x squared minus 6x plus 9. I have, because of the x squared here, I've got a quadratic equation. For solving quadratic equations, we want to make it equal to 0. So I'm going to subtract the 24 to get it over here to the other side. And I have to add 4x. So now over here, everything canceled out. So we have 0. This is going to be 15. And now we want to solve using ideally factoring. In this case, I need a pair of numbers that multiply to be -5 and add to be -2. That would be x minus 5 times x plus 3. And remember, when it's in factored, we set each factor equal to 0, and we get x equals 5 and x equals negative 3. Now, under a lot of circumstances, that would be our answer, but because it's a radical equation, we must check those answers, and we must plug it into the original equation. So if I check the 5, I get square root of 24 minus 4 times 5 equals 5 minus 3. This would be the square root of 24 minus 20, which is the square root of 4, which is 2. And over here I get 2. That checks out. So this answer, the 5, is good. If we do the negative 3, let me do it a little higher here on the left. We've got square root of 24 minus 4 times negative 3 equals negative 3 minus 3. So over on this side, we get the square root of 36 equals negative 6, or 6 equals negative 6, which is not true. It's false. So this is an extraneous answer. Nice word. And so our final answer is x equals 5. You have to check both answers. They could either neither of them might be extraneous, they could both be extraneous, in which case we would have no solution, or in this case, only one of them was extraneous. Now our last problem, function notation. Function notation means plug it in and calculate. F matches with the F here, so we're going to plug negative 9 in for the x. So I've got 3 minus negative 9 squared. Make sure you put the negative 9 in a parentheses, especially if you're using the calculator. Negative 9 squared is 81, so I have 3 minus positive 81, which gives me negative 78 for the first problem. Again, if you're doing the calculator, make sure we use those parentheses. 3 minus parentheses negative 9 parentheses squared. That gives us the correct answer. If I did 3 minus negative 9 squared, we get the wrong answer. So don't make that mistake. Number 2, this time we're going to plug into the g function. So I'm going to plug the negative 5 over here. So we've got 5 minus 2 times 5, which is 5 minus 10, which is negative 5. Now the last two examples here are called composite notation. We start at the inside. So the inside is this here, g of negative 5. So we calculate that. Now I made this one, we just calculated g of 5. So g of 5 is negative 5. So we've got f of negative 5. So again, I calculated this and put its value inside. For that, I did a substitution. Now we can substitute negative 5 into my f function, paying attention to your negative signs again. So we get 3 minus 25, or we get negative 22. That number is our final answer. Finally, for here, we've got to calculate f of 3 first. So we've got to calculate that first. So that would be 3 minus 3 squared, which is 3 minus 9, which is negative 6. So now we are evaluating g of negative 6, replacing f of negative 3 with that, and we plug into our g formula, which gives us 5 plus 12 is 17. So I hope this helps prepare you for our final quiz of the second marking period, and best of luck to you.